So, when naming bases, there's a major problem. Every base calls itself base 10. It's pretty obvious. For us, people who are accustomed to using decimal is base 10. But for people who use what we call base 20, their base is base 10 for them. So, I have thought of three methods to solve this. I'd like to preface this by saying a lot of people have thought of more intelligent methods than I have. Okay, this method is probably pretty dumb. These methods, these three, I'm going to tell you, they all have advantages and disadvantages. First, I'd like to tell you the first option, base x. While x being the biggest single digit value in the base. For example, base 1 being binary, base 2 being ternary, and base 9 being decimal. Of course, this offers a few problems, but let's focus on the benefits first. First benefit, we have it's easy to use and to implement in your daily life because it only has like one number for bases less than your current base, and it probably never has more than like 5 numbers, even if you're using weird bases. A disadvantage, of course, is that most people might not understand this, and that can be a problem. And there's also the second disadvantage, which I'm not gonna say now because it's important to show the next option before saying it. So option 2, which is base x plus 1. X continues to be the largest number in the base, which means base 1 plus 1 is binary, 2 plus 1 is ternary, 9 plus 1 is decimal. Firstly, this fixes one of the issues. 1 plus 1 is 2, so even if you don't like this, you're just gonna evaluate in your mind, oh, base 1 plus 1 is gonna be base 2. This solves this, but this has another disadvantage, which is the fact that it uses like plus 1, which are 2 extra digits. And there's also the disadvantage B, which also applies to this one. The disadvantage B is that if someone uses the numbers we use, but does not use decimal base, they will not know what 9 or what 8 or what 7 is if it's not on their base, which is fixed by option 3, which is base 1 plus 1 plus 1 plus 1 plus 1. You don't actually have to sum. You can multiply, you can exponentiate, you can take roots, though I don't know why that would be needed. This base is way harder to write, because you gotta use like 1 plus 1, 1 plus 1 plus 1, 1 plus 1 plus 1 plus 1 plus 1, which evaluates to 5 times 1 plus 1, evaluates to 2. This all evaluates to our 10 decimal. So I've included some examples, of course, in both of these bases. I had included one here, but it has disappeared. So yeah, that's it. These are my 3 options, and that is all. I mean, of course, every single one of them has their advantages and disadvantages, but, well, that's it. Of course, it's not like anyone's gonna switch up their base, the base that they're currently using. No, I'm not gonna do that. I'm gonna still name base decimal with a 10, binary with a 2, dozenal with a 12. But it's a fun alternative. So yeah, thanks for watching. Bye.